Hello, and welcome to TED Talks. Our security edition today is focused on testing your SIEM with Splunk ATT&CK Data Repository. TED Talks is a series of short webinars focused on features and best practices. We value you, our customer, and want you to continue in your Splunk journey. Our experts help create these tips and tricks, and we want you to leverage them in your daily role. I'm Jairo Camacho, a product marketing specialist focused on user behavior analytics. I'm excited to share how detection testing can help bolster your security posture. I'd like to introduce my colleague, Patrick Burrice.
Hi everyone, my name is Patrick. I'm a senior security research engineer at Splunk research team. I've been with Splunk for more than 1 year, and I'm focusing on detection development and detection engineering in Splunk.
Awesome, thanks Patrick. Today, we will discuss the regular tasks that accompany managing a SIEM, outline the anatomy of an attack dataset, delineate the steps for attack dataset creation, showcase the attack dataset consumption, then provide additional resources to support you on your journey. Our team will be available for Q&A throughout the TED Talk or a Q&A widget within your screen. And if you happen to watch a recorded version of this webinar, please continue the conversation through the TED Talk discussions in the Splunk community. Security operations centers are on the front line, protecting their organizations against any potential threats. However, for many teams, detection development and testing falls between the cracks. Enterprise security and enterprise security constantly provide customers a steady stream of new detections, but more detections are typically needed that focus on seeing their unique environment and needs. Many factors impact the testing of detections: logs, tech add-ons, parsing rules, etc. To ensure your detections are working properly, it's imperative that you regularly test. The labor shortage in security has been well documented. It's tough to retain talent, so training must be made a priority to ensure your new analysts are brought up to speed quickly. Having dedicated data sets for training can help ramp up their ability to write detections and pinpoint attacks. Now I'm going to hand things over to Patrick.
I prepared 3 examples which will describe typical SIEM tasks and how you can perform them more efficient with attack data. Let's get it started. Let me introduce you Abby, SOC manager, and Ellie, who works as a SOC analyst. Abby listened to some interesting security talks during .conf 2020, and her key takeaways have been that credential dumping is an often used attack vector for adversaries. Therefore, she wants to be able to detect these kind of attacks. Ellie, as a SOC analyst, got a task to develop detections for various credential dumping techniques. In order that she's able to do this, she needs a detection lab. Therefore, she starts to build her own lab and begin with building the Windows server. Then the Splunk server, followed by configuring Splunk with all its configuration file and .conf files. The next step is installing and configuring Sysmon. Sysmon is a Windows sysinternal tool which gives you additional visibility in your Windows machine. Then she installs the attacking tools, which she uses to perform various credential dumping attacks. And finally, on the 6th day, she starts to develop detection. This is only an example. In reality, these tasks can take a lot longer. Ellie needed a total of 8 days for developing these detections and wasted 5 out of 8 days with building the lab. But what happens if somebody else already performed credential dumping attacks and stored these log files into an attack data project? She could reuse this data by downloading it and indexing it into her Splunk server. And afterwards, she can directly start to develop detections. In this case, Ellie only needed 4 days and could spend the majority of time on detection development. We learned that attack data can help you to accelerate detection development. Let's have a look into another example. It's 6 months later, and Abby wants to know if all the credential dumping detections are still working. Abby gives Ellie the task to test all the detections and ensure that they are still working. Ellie downloaded different attack datasets for credential dumping from the attack data project and indexed the datasets into Splunk. Now she has different credential dumping attacks in Splunk. Then she is able to execute all the detections and check if the detections are still working. Luckily, all the detections are still working, which makes Abby very happy. Ellie did a great job over the last year and was promoted to SOC manager. She got a new hire called Olaf, who is a threat hunter. Ellie gave Olaf the task to find the attack in these datasets. Olaf is a very talented guy. Therefore, he was able to find the attack in a couple of hours. He learned a lot about threat hunting during this exercise. Let me summarize the benefits of attack data. Attack data can be used for detection development, detection testing, and training of SOC analysts and threat hunters. Let's talk about anatomy of an attack dataset. The attack data project is available as an open source GitHub project, which you can find under this link. The project contains of two high-level folders. The first one is called Environment and includes a description of the environment. The second one is called Datasets and contains the datasets. The Environment folder contains description of the environment used to generate the attack datasets. The environments are described as markdown pages and contains information about users, computers, and configuration of the environment. The Datasets folder consists of multiple subfolders, which are named based on the MITRE-TECHNIK IDs. For example, the folder with the MITRE-TECHNIK ID T1003.001 consists datasets with OS credential dumping attacks targeting the LSAS memory. The subfolders under datasets contain YAML files, which provides metadata for the attack datasets. Metadata for the attack datasets is very important in order that the user knows what kind of attacks or technique were executed in these attack datasets. It helps you to find the right dataset for your need. Let's have a closer look into a YAML file. On the top of the YAML file, we have some metadata about the creator of the dataset, the date, and some description. In this case, Atomic Red Team was used to simulate the OS credential dumping attack targeting the LSAS memory. Then we have the environment. The environment needs to match the environment in the environments folder. We will see later an example for that. In this case, our open source project attack range is used to generate a dataset. The environment is followed by the technique. In this case, the MITRE-TECHNIK ID T1003.001, which stands for OS credential dumping LSAS memory. Followed by the dataset. The datasets are stored in AWS S3. These datasets are available under the given links. The reference field helps you to get more information about the MITRE-TECHNIK and the executed Atomic Red Team attack. You can learn more about the technique and the attack by visiting the links. And last but not least, we have the source types. Source types help you to specify the right source type when you index these datasets into your Splunk instance. These datasets consist of Windows Event Log security, system, application, and sysmon logs. Here you can see an example of an environment. The environment is a wiki page which describes the server, user, and configurations of the environment. It should provide all the information you need to understand the environment in order to use the dataset. Dataset consumption. Let me explain you how you can use the dataset. There exist two ways of indexing the attack dataset. The first way uses the Splunk UI to index the datasets. Let me guide you through the process. First, you choose the dataset from the attack data project. Second, you download the dataset from the attack data project to your local file system. Third, you use the button Add Data, which you can see in the slide, to index the attack datasets. Doing that, you will be guided through the process from the Splunk UI, you just need to make sure that you use the right source types which are given in the attack data YAML file. Another option to replay the attack data is to use the attack range and its built-in command replay. The attack range is a detection development platform which solves three main challenges in detection engineering. First, the user is able to build quickly a small lab infrastructure as close as possible to a production environment. Second, the attack range performs attack simulation using different engines such as Atomic Red Team or Caldera in order to generate real attack data. Third, it integrates seamlessly into any continuous integration and continuous delivery pipeline to automate the detection rule testing process. The attack range environment consists of multiple Windows server and a Splunk server. Everything is already pre-configured and you can use it out of the box. The second way of replaying attack data is the replay command, which will take the downloaded attack data set and index it into the test index of the Splunk server of the attack range. Afterwards, you can use the attack data for detection development, detection testing, and training. I prepared a small demo for you. In this demo, I executed the Ariake ransomware in the attack range. The attack data is then dumped from the Splunk server and replayed to another Splunk instance. Then the attack data is used to test the detection capabilities of Splunk Enterprise Security. Let's start with the demo. At the beginning of the demo, we will run the Ariake malware. The Ariake malware is a ransomware. Ransomware is a category of malware that logs all your files of the system and holds them hostage for ransom. Ariake is a type of ransomware used in the targeted attacks, where the threat actors make sure that essential files are encrypted so you can ask for large ransom amounts. A typical Orion ransom demands can amount to few $100,000. Okay, let's execute it. We can see that the ransomware Ariake starts to encrypt our complete drive. You see, like, we had there some Caldera agents which we use for threat simulation. They are now encrypted. You see it's now a .ariake file. Then we can see the ransomware nodes. In this case, you see it's from Ariake. You have some protomail, email addresses, and then it calls balance of shadow universe. In the next step now, we collected all that data with the Splunk server, and we will now dump that data from the Splunk server that we have it as attack data. So now we want to dump the data from the Splunk server to our local file system. For that, I will use I'm using the attack range local, and for that I'm using the action dump and give a dump name. In this case, I use Ariake malware as a dump name, and I will execute it. And this will create a folder called Ariake malware in here in the local file system under attack_data. And there you see the different Windows logs. For example, here we have the Windows security logs, or here, for example, the sysmon logs. The first option to replay attack data to our Splunk instance is using add data. We click on add data. We click on upload. We are selecting the file from our local file system. You see, like, I'm here now in attack data, Ariake malware. And now I want to ingest, for example, the security logs. I open them, click on next, Set the source type to XML Win event log in this case. The parsing looks good. Splunk server as a server is okay, and we will use the index test because it's our test data. We click on review, click on submit, and we start searching. Now we can see that our tech data is now in our instance, and we can use it to run different SPL queries. Now I want to show you another way of replaying attack data in case you're using the attack range. There's a built-in replay command. Let's have a look how this replay command works. I will use the action replay and then the dump name called Rike_malware, and I will execute it. Now the different attack data will be replayed in the attack range, and we will have the data in the test index, and we can use it. After replaying the attack data, we will use these data in order to test the detection capabilities of our enterprise security. For this test, I activated a bunch of our ransomware detections, and I'm curious if our detection were able to detect this Rike malware infection. For that, I will click on Incident Review. We can see that different detections were able to detect the Rike ransomware infections. The urgency of them are all medium because I didn't configure asset and identities. In a production environment with configured asset and identities, you would have critical, high, medium, and low notables, depending on the criticality of the assets and identities. Let's have a look into the different detections. The first detection looks for common ransomware nodes. This is one of our generic detections which detects the ransomware nodes files which are created from the ransomware. In this case, it was on the Windows client which you used to generate the attack data, and it was the Rike readme.html which was created. Then we have also more precise detections for Rike malware. In this case, it's the same kind of detection which detects the ransomware nodes, but dedicated, we already know this is Rike. And a third detection we're able to detect the malware. In this case, the malware tries to stop the Windows Security Account Manager, and this was detected by one of our detections. In this short demo, we learned how we can use attack data to evaluate the detections in our enterprise security. You can do the same process in your environment by using our attack data, replaying it to your enterprise security, and have a look if you're able to detect this kind of attacks or not. Thank you very much.
Thanks, Patrick. We have some great resources available for you to learn more about how to test your SIEM Splunk attack data repository. Check out the education at .conf session. They are filled with great insights. All of these links will be sent to you in a follow-up email along with the recording of this TED Talk. Finally, don't forget that we have an incredible community of Splunk users on our community website. There you will find a Q&A section that you can use to learn more about how to test your SIEM with Splunk Attack Range. Also, feel free to participate in the new discussions section with Security TED Talks and Splunk Ideas, the place to submit new ideas you might have for product enhancements. We really appreciate you taking time out of your busy schedules to join us today. Please tune back in for future TED Talks. We are really excited to share this series with you. Thanks again.